Welcome to 2.2 Characteristics of Quadratic Functions, Part 1. What you'll learn in this lesson is to explore properties of parabolas, find maximum and minimum values of quadratic functions, graph quadratic functions using x-intercepts, and solving real-life problems. The first thing we'll look at with parabolas is that they actually have an axis of symmetry. They are symmetric. So if you remember what an axis of symmetry is from geometry, same idea in Algebra 2. It's a line that divides the parabola into mirror images, and it always passes through the vertex. The vertex, if you remember, is the very bottom of the U-shaped value or U-shaped function. It is either the minimum value or the maximum value, depending on which way your parabola opens up. The vertex form, if you remember, is a times x minus h squared plus k, and hk is the vertex. And the axis of symmetry goes right through there. So we're going to use that to graph parabolas. Let's look at example 1. Using symmetry to graph quadratic functions. So let's take a look. We need to graph f of x equals -2 times x plus 3 squared plus 4. Label the vertex as an axis of symmetry. So the first thing we're going to look at is what's the vertex. That's the first thing you should identify. The vertex is, remember we take the opposite of that for the x value, so that's -3. And then the y value is on the outside, so that's +4. So we graph that. So -3, +4. The axis of symmetry goes right through that. So let's label that vertex. Sorry. And then let's look at the axis of symmetry. Now this isn't part of the graph, but you can sketch it and it helps you graph the function. So this is the axis of symmetry. All right, so let's find another point. So let's do a t-chart. And we're just going to pick one point at a time. So let's put in -2 because it's on the right-hand side of my axis of symmetry. So I'm going to plug it in. -2 times -2 plus 3 squared plus 4. So that is 1 squared. 1 squared is 1. 1 times -2 is -2. -2 plus 4 is 2. So there's your there's another point. So -2, +2. So right there. Now we're going to use symmetry. So since our parabola is symmetric, let me see. Get you a pointer. From the axis of symmetry to this point is 1 unit. So we can reflect this over the line and plot the other side of that parabola right there without even having to do any other math. Let's find another point. So let's plug in -1. So let's do some more calculations. So let's plug in -1, so -2 times -1 plus 3 squared plus 4. So that's -2. -1 plus 3 is 2. 2 squared is 4. -2 times 4 is a -8. Plus 4 is a -4. So graph that point, -1, -4. Again, we're going to reflect this point over the line to get the other side. So that gives us this point. So with half the work, we have a full parabola with plenty of points. So let's sketch. So nice smooth curve, nice smooth curve. So there's your parabola. We labeled the vertex and axis of symmetry, so just double checking that we did everything we needed to do. Okay, but that was in with your function, your quadratic function in vertex form. So let's take a look at another form. Let's look at standard form. Quadratic functions can also be written in standard form. ax squared plus bx plus c, where a is not equal to 0. So you have to have that x squared term. That's what that means. You can derive the standard form by expanding the vertex form. So let's take a look at it. So let's do that with example 1. We get negative 2 times x plus 3 squared plus 4. So we're just going to expand this. Now we need to expand the x plus 3 squared. That is not x squared plus 3 squared. That is a very common mistake. You have to write this out as x plus 3 times x plus 3. And then you have to, and some of you guys learned how to FOIL, same idea. We're going to distribute, FOILing. So x times x is x squared. X times 3 is 3x. 3 times x is 3x. 3 times 3 is 9. Bring down your negative 2. I haven't multiplied by that yet. And bring down your 4, plus 4. I'm going to simplify what's inside parentheses first to make this a little bit easier. So that's plus 6x. Combine the x's. Then we'll distribute the negative 2. So this is negative 2x squared minus 12x minus 18 plus 4. Combine the two constants. And you get negative 2x squared minus 12x minus 14. So we can take vertex form and turn it into standard form. For that. Some other properties of the graph, ax squared plus bx plus c. C, this, oh, whoops, thought it was a highlighter. So this C right here is your y-intercept. This C right here is your y-intercept. It's where it crosses the y-axis. So if you have it in standard form, you know where it crosses the y-axis at. It's easy to pick out. Now another thing, the vertex, the axis of symmetry, sorry, is negative b over 2a. We can calculate it. So you take the opposite of b divided by 2 times a. Okay, you use those two values there, and you can find your axis of symmetry and graph it. Again, like the absolute value functions, if a is greater than 0, it opens up. If a is less than 0, it opens down. In other words, it's negative. If they say the absolute value, they're just looking at the number without the sign, okay? If it is greater than 1, then it's wider. That means it is a vertical not wider, narrower. Sorry, I went backwards. It is narrower, okay? That is a vertical stretch. If a is less than 1, the absolute value is less than 1, between 0 and 1, that is a vertical shrink, means the graph is wider. So you can kind of keep that in mind, okay? Again, they state the axis of symmetry. We can calculate that using that formula. And the cool thing is that our vertex happens on that line, okay? So you can steal the x value from the axis of symmetry and put it right there. And then we plug in. We plug in our value into our function, our x value into our function, and find our y value to find the vertex. Okay? And obviously we can graph the y-intercept, which is 0, c on the parabola, and that gives us 3 points. So let's do that. Okay, we're just learning a little bit more about quadratics. So here we go. So the graph of f of x equals 3x squared minus 6x plus 1. We need to label the axis, symmetry, and the vertex. So the first thing you want to do is you want to find the axis of symmetry. The axis of symmetry is x equals negative b over 2 times a. So you need to figure out what's what. Well, the first coefficient of x squared is a, the coefficient of x is b, including the sign, and the number, the constant, is c. So we know what our numbers are. So let's plug in negative b, so negative 6, so that's a positive 6, over 2 times a is 3. So this is 6 divided by 6 was just 1. So our axis of symmetry is x equals 1. So let's graph that. So there's our axis of symmetry. All right, so our vertex is on that line. Our vertex is on that line. So our vertex, we're going to steal the axis of symmetry x value, because that's our x value, but we do not know what our y value is. So let's find that. Okay, let's do a little think cloud and do a little bit of math over here. So we have our function, and we're going to plug in 1 into our original function. So 3 times 1 squared minus 6 times 1 plus 1. So 1 squared is 1, 1 times 3 is 3, 6 times 1 is 6. So this is negative 3 plus 1 is a negative 2. So there is our y value of our vertex, 1, negative 2. So there's our vertex. Notice it's on the axis of symmetry, and it should be. Okay? Now, we have another point that we don't even have to work for. Okay? But we do need to write it down. So we have our y-intercept, and we just steal the c value. C is 1, so it's 0, 1. So that's where it crosses the y-axis. And because we know it reflects, we can reflect this point over that axis of symmetry and graph the one on the other side of that. So now I have 3 points. Another thing we can tell that we need to like write down, does our graph open up or down? So since a is positive, this graph opens up. So I'm just going to write that down, and I'm going to put y. A is positive, because these are nodes, so we want to, and we know a is 3. Okay, so a is positive. It's 3. 3 is positive, so we know it opens up. Now we can totally sketch this. 3 points is enough, but if you wanted an extra point, you can always do a little t-chart and get a better graph. So let's do that, because I like to be a little more accurate. So x, y. So I'm going to plug in, either I can plug in 3 or I can plug in negative 1. It doesn't matter. I'm going to plug in 3. So f of 3 equals 3 times 3 squared minus 6 times 3 plus 1. So we get 9 times 3 is 27. 6 times 3 is 18. 27 minus 18 plus 1 is 10. So we get the point 3, 10. So 3 up to 10. And we can reflect that over the axis of symmetry. So it's 2 units to the right, so 2 units to the left is another point. So that'll help us graph a more accurate graph. And let's sketch our graph. So nice and smooth. Nice smooth parabola. So these are all just kind of shortcuts to graphing better parabolas. Okay, it's to save you time from doing a whole bunch of points on your t-chart. These are important features. We need to know how to identify them and make sense of them. All right, finding the maximum and minimum values. Because the vertex is the highest or lowest point on a parabola, its y-coordinate is the maximum value or minimum value of the function. The vertex lies on the axis of symmetry, so the function is increasing on one side of the axis of symmetry and decreasing on the other. So let's take a look. We're just learning how to talk about them. So if we have a minimum, which is our vertex, that means our U-shaped up. On the left-hand side, we're decreasing, and on the right-hand side, we're increasing. That's all we're talking about, okay? The minimum value is your vertex, and it's the y value of your vertex, because that's the height. That's the maximum height, okay? Or the minimum height for this case. This will be your maximum height. Domain is all real numbers. Again, it goes as wide as can be. The range is y is less than, or I'm sorry, greater than this point. If this is a minimum, my height gets only higher from this point. Decreasing to the left of this, and it's increasing to the right of your vertex, okay, your x values. The minimum, this is a maximum value, so I have a maximum value height at whatever that is. It could be any number, but the y value is your maximum height. You're talking about the height there. Domain, again, is all real numbers, and your range is y is less than this height. So that means your graph goes down. It only gets lower from there. It doesn't get any higher. Increasing to the left, so it's increasing and decreasing. I always tell my students, you read from left to right, you read a graph from left to right. So you start on the left, and this side is increasing, and then it's decreasing. It's like a roller coaster, okay? And this says it's decreasing on the right. So let's take a look. Find the minimum or maximum value. So we need to find the minimum or maximum value of this function. Describe the domain and range of the function and where the function is increasing and decreasing. So we're going to do this without even graphing. So the first thing we have to do is we need to find our vertex. Okay, we need to find the value of our vertex. So we find the vertex. Now, we don't know the x value. Well, we can find the x value because we know the equation for axis of symmetry. So we know the x value of our vertex is negative b over 2 times a, because it lies on the the axis of symmetry. So I'll plug in. So negative b, so it'd be positive 2, it's the opposite of whatever b is, divided by 2 times a is 1/2. So this ends up being 2 over 1 or just 2. So I get my x value of my vertex, which is 2. Plug it back in to find my y value of my vertex. So we plug in f of 2. So we get 1/2 times 2 squared minus 2 times 2 minus 1. So that's 2 squared is 4. Half of 4 is 2. 2 times 2 is 4. 2 minus 4 is negative 2, minus 1 more is negative 3. So I get the point 2, negative 3. There's your vertex, okay? That's an important information, so I'm going to highlight that. Okay, so there's my vertex. All right, so what else do we need? We need to, is this a minimum or maximum value? So we need to state it as a minimum or maximum. So let's take a look. This is positive. That a value is positive, so that means this vertex or this parabola opens up. So without even graphing, I know it's shaped like this, right? So we have a minimum value. So this is a minimum value. And it reaches a minimum value of negative 3, okay? The height reaches negative 3. That's the idea. The minimum value is the y value. Okay, of your vertex. So there's your minimum. So it bottoms out at the height of negative 3. The domain, this is a parabola, so it's all real numbers. Yes, I'm going to take my shortcut there, double barred R. The range, let's look at the range. So without even graphing this, if this is the negative 3 is the minimum value, means I can get higher than that. So y is greater than or equal to negative 3. Okay, so I can get higher than that. Now we talk about increasing and decreasing. All right, so thinking about what opening up looks like, it's going to decrease to this x value, which the x value is 2, and then increase again. Okay, so let's write that down. So we are decreasing when x is less than the 2 value, so it's to the left, and it is increasing when x is greater than 2, to the right. Okay, so again, think about opening up. It's decreasing until this x value, and then it increases again. And that's what I said. When x is less than 2, that's the left-hand side, it is decreasing, and then it's increasing. So let's take a look at this on Desmos, just so we can get a visual of this. All right. Oh, I might have to move that. That's okay. All right, so let's graph 1/2. Parentheses. I didn't need parentheses. We'll just go with it. 1/2 x squared minus 2x minus 1. Okay, it opens up, okay? And if you look here, you can tap on your point, you get the vertex of 2, -3. It opens up, the minimum value, the minimum height is -3, we can see that. The domain is all real numbers, it gets y as it can be. The range is y is greater than or equal to -3, so it goes higher. And now let's look at our decreasing, increasing. Oh, I didn't mean to move that. I don't want to move this. Oh, that's cool. Looky there. I moved something I didn't know I could move. Okay, so let's take a look. We said it's decreasing x is less than 2. So here's the x value as 2. It is decreasing on this side, and we're right. And then x is greater than 2, that's this way. It is increasing again. So everything's correct. I can visually check what I just figured out.